Let's turn this dream into reality and attempt to lift this kid with balloons. Imagine a kid weighing 50 kilograms. We give him helium balloons. These balloons apply a force against gravity. How many of them do we need to counteract the gravitational force and keep the kid afloat in the air? Before we calculate this, let's delve into Newton's laws. In 1687, Newton published a book called Philosophiæ Naturalis Principia Mathematica, simply known as Principia. In this book, Newton explained the three laws of motion and universal gravity using the calculus that he invented. In this video, we will try to achieve flight using Newton's three laws of motion and the law of universal gravitation. By employing these formulas, we can determine the effect of gravity and calculate how many balloons are necessary to fly the kit. First, let's learn about these laws. According to the law of inertia, an object at rest will remain at rest, and an object in motion will continue moving at the same speed and in the same direction unless an external unbalanced force is applied. Here the man is flying because he wants to continue moving at the same speed. The acceleration of an object depends on its mass and the amount of force applied to it, expressed as F equals m times a. To understand this, we need to know the difference between mass and weight. Mass is like how much stuff is in something, and it is the same no matter where you are, moon or earth. Weight, on the other hand, is how hard gravity is pulling on an object, and that can change depending on which planet on you are. This law informs us that an object subjected to an external force will accelerate, and the magnitude of this acceleration is directly proportional to the force applied. Additionally, the acceleration is inversely proportional to the mass of the object. For equal forces, a heavier object will experience less acceleration than a lighter one. Newton's third law states that for every action in nature, there is an equal and opposite reaction. That's fair. When one object exerts a force on another, the second object exerts an equal and opposite force on the first. While these laws form the cornerstones of physics, they can explain many mechanical motions. With the aid of these three laws, Newton also elucidated universal gravity in the same book. Noticing that an apple fell to the ground and wondering why the moon didn't fall onto the earth, Newton realized that objects are pulled toward the earth by a mystical force. To investigate this further, he shifted his gaze from the earth to the sky. The reason for the apple's descent and the moon's avoidance of falling onto the earth was the same. In fact, both the moon and the apple are falling toward the earth. So why the moon doesn't crash to the earth? Because the moon is also moving rapidly in a horizontal direction. While the moon is falling toward the earth, it is continuously maintaining its horizontal velocity, and these two forces are balancing each other to keep the moon in orbit. According to the law of universal gravitation, every object in the universe is attracted to all other objects by a force that increases as the masses of the objects grow and as they get closer to each other. In the 19th century, astronomers observed that Uranus didn't follow a simple orbit. It seemed as though its orbit was disrupted by another celestial body. Using Newton's laws, they conducted calculations and discovered a deep blue planet in 1846. This planet was named Neptune in homage to the sea god. Today, many technologies such as airplanes flight, rocket launches, satellite orbits, and automobile braking are designed and succeed based on Newton's laws. Now that we have reviewed these laws, let's revisit our attempt to make the kit fly. To lift a 50-kilogram kit using helium-filled balloons, we must calculate the buoyant force exerted by the balloons, which must overcome the force of gravity pulling the kit downward. First, let's see what is the gravitational force. In this formula, mass of the kit is 50 kilograms and G is 9.81, which makes 490.5 newtons. The F power these helium balloons have can be calculated with Archimedes' principle, which states that the buoyant force equals the weight of the fluid displaced by the object. We will learn about it in another video, but briefly, this is the formula for buoyant force. When we calculate this, we find out that this much helium is needed to beat that gravity. A regular balloon can contain this much, so we need around 2722 balloons to make a kit fly. Now, do whatever you want with this information. If you want to see more of these videos, subscribe to support us. Thank you for watching and we will see you next week.